All right, CNT140, we're continuing on with Chapter 3 here. The standards also recognize doing passive optical LANs based on fiber to the home technology. So you could have fiber runs from a closet out to switches at various parts of the building, and then copper from there out to workstations. And that, instead of having all the infrastructure with the copper out to outlets and everything, you could actually have a lot of fiber connecting things together, and giving you, less of the equipment needed out in the closets and floors. We think of structured cabling for and networks, data networks, if you will. It's actually also used for plenty of other things. Sometimes we have these setups in residential areas, homes. Sometimes in buildings, the part of the network is used for, or it might be a network used for security systems, might even be used for industrial controls, building lighting, air conditioning, heating, cooling, that sort of thing. Even management systems, as they're saying here. And also for running other types of systems on top of. So here, just reminding you, I might actually have security equipment attached to my network, or I might have a separate network with security equipment, cameras, those sorts of things, name badges, swiping in, and that sort of thing. Or again, it might be on your data network off in its own VLAN, if you will, some aspect of your network. Here is some closed circuit television. Might actually have its own network or be attached to your data network and running through. Alarm systems, that sort of thing. Industrial applications, we have a lot of equipment that's controlled through networks now. Robotic arms, conveyor belts moving product, scanners scanning product, those sorts of things. A lot of these things are part of networks now, or attached to networks, or their own type of network. So we have a lot of equipment like that that might be connected to or have its own network for communicating information. So I just kind of grabbed an example here of, I might have the actual data part or the business part of the network here, but I actually have the factory floor out here, and there might be two networks, or these might interconnect at some point, depending on the facility. Residential networks have grown. More and more houses actually have small networks put into them. Some still rely on the whole, one or two connections, and the rest is wireless. But some residential areas actually have, or residences actually have their own data network in. Probably mostly copper, but a lot of times there's fiber coming to the side of the residence and copper inside. Combination of coax or unshielded twisted pair. And I grabbed this stat. The book had a stat in here about the number of fiber connections to the house. I grabbed a more up-to-date one from this past summer. As the fourth quarter of 2023, more than 2/3 of fixed broadband connections worldwide were fiber to the home. And that's, in our area, we think of Verizon, Fios, and that sort of stuff. But there's a lot of other providers that are actually bringing fiber to the side of your house. And then that unit on the side of your house might be converting into coax or twisted pair for internally in your house. This is a reminder of doing a DSL type connection into your house, where it gets to your house and then split inside into phone line, data line, TV line, that sort of thing. But I might also have a cable network. Again, there might be fiber coming to the side of the house, and it's converted into coax or twisted pair inside the house. So as it comes into here, I might actually have some mixture of coax lines and twisted pair lines to connect my devices together. If I have fiber to the home, here I literally have fiber come to the side of the house, and the ONT unit is going to convert that into potentially a regular phone line, a regular twisted pair line to desktops or routers, and I might actually have a coax line going to my set-top boxes and TVs and that sort of thing. There are standards for structured cabling in residences and industrial, TIA 570 and TIA 1005. These are standards that specify how things should be done residentially as well as industrial. 570 allows for the use of UTP as well as coax for connections. Like we said, as we look back here, I might have a mixture of twisted pair and coax. I might even have a mixture of twisted pair and coax, depending on my connection to my house.
Some consumer electronics use inexpensive plastic optical fiber. So a fiber that's plastic core instead of glass core, and used for toss links or firewire. They're not considered part of the 570 standard because they are local connections. However, we should at least recognize the Toslink Toshiba link. This is an optical fiber that I use for audio connections, usually audio connections, and I might have a FireWire connection that is used for data, high-speed data, if you will. Okay, so just recognize those might be some local connections, not part of the standard, but some local connections. As we move into data centers have increased the amount of data they need to process and move through, especially as we started adding in not just data, but actually streaming of video and audio on top of all the existing data and potentially phone traffic that's moving through. So because of that, your data centers need extremely high-speed connections. So they're either using category 6A or special coax cables or fiber to handle the 10 gig links that are needed. So with that, and actually they've developed a category 8 for short links, 30-meter links at 10 gig. So there's a mixture of things that get used in data centers. A lot have moved to the short, category links or fiber. A lot of times they're doing a lot of fiber connections in between. Here's the category 8 showing you we have shielding around each pair plus shielding around the whole cable, if you will. Not widely supported, but just be aware that it's there. A lot of data centers are using fiber optic links to connect racks and switches and racks together and so forth, servers and switches together. And they tend to use a lot of wavelength division multiplexing, so you can have a lot of signals going across one fiber cable, reducing the amount of fiber cables that are needed. Showing you here, I might actually have fiber patch panels. These are passive devices, so I can make a connection from a switch to a fiber optic patch panel over to another patch panel in the top of a server cabinet that it might use multiple connections down to the individual servers that are in here. So I'm showing you a patch panel and actually some fiber switch connections there. There are standards for data centers. They mentioned here the Open Compute Project and the Open 19. These are trying to get some of these connections standardized. A lot of them based on single mode fiber for connections between your servers and devices in your data center. All right, we're going to move into some UTP cabling now for networks. So UTP, standard UTP used for networks, we talked about previously, four pairs of wires. My first generation was your 10 meg. That was the first hub network, used star topology hub network. So our 4-pair twisted pair cabling, I was only actually using 2 pairs out of there. As we moved into fast Ethernet, 100 meg, it still managed to work on 2 pairs to move our data around. When we moved into gigabit, 1000 meg, gigabit, it was necessary to now actually use all 4 pairs simultaneously in both directions. When we moved into 10 gig Ethernet, 10 gigabit per second, now required additional development of special cabling to handle the higher bandwidth with a higher frequency. Again, using all 4 wire pairs. The book had a chart in there kind of breaking down the whole with our bandwidth, what categories of cabling would support that. Category 3 would support your 10 base. Category 3 would support your token ring 4 meg. And Category 4 came along to support token ring 4 meg. Category 5 for 100 meg fast Ethernet. Category 5E for gigabit Ethernet. And it took a Category 6A to support your 10 gig Ethernet. And there is a Category 8, like we mentioned with the data center, that can support 25, 40 gig, if you will, at short distances, 30 meters or less distances. Okay. So, looking at unshielded twisted pair, as we said, categories were developed to identify what it would be able to support. So, refreshing these for you again, we started off with phone cabling, non-paired flat cable. That was good for, K of bandwidth, 14.4K of bandwidth in the days of modems and dial-up modems.
When we moved into starting to get away from the coax and go to the twisted pair star, they started using Category 3 cabling to support your 10 meg networks. Well, the Category 3 cabling has just the slight twist in the pairs for cancellation. So your Category 3 was able to support your 10 meg networks. As we move to Category 5, the twist pitch gets more significant. And they actually were doing a variation in twist pitch between each of the pairs. So you did not have less chance of crosstalk between the pairs. We'll put it that way. 5E, this was done more diligently, and actually the quality of components were a little bit better to be able to support gigabit. So 5 was able to support your 100 meg. 5E was able to support your initial gigabit, if you will. Moving to Category 6. Category 6 came along, and they actually, again, paying attention to the twist here, getting more diligent, and actually using a divider in the middle to keep those wire pairs separated to reduce the possibility of crosstalk as the frequency of the signal going through the cable is increased. And then 6A comes along, we take that same structure, now we put shielding around the outside, allowing us to use a higher frequency to carry more data. Now we can get into the 10 gig range. With your Category 6A, we can get into the 10 gig range. As we mentioned earlier, Category 8 developed for data centers to be able to handle the 10 gig links or 25 or 40 at shorter distances, 30 meters instead of 90 meters. The book mentioned splitting a twisted pair cable to handle 2 data links or a data and a phone link. I put a little reminder here that's old school. Most connections you don't do that now. But there was a day when you were dealing with less bandwidth that you could take one piece of unshielded twisted pair, since you were only using 2 pairs in it, and 2 pairs could support one data link, the other 2 pairs support a different data link, or 2 pairs support a data link, the other 2 support a phone line kind of thing, and reduce the amount of cabling you would need. Not supported in standards today. Just put that out there. So that's why I put a little old school in front of there. Fiber is typically used as a backbone for our networks, like we've mentioned a couple different times. So as I look at my network structure here, twisted pair cabling from the closet, patch panel out to outlets in the work area. In the closet then, connection from closet here on the second floor to the first floor, connection from this switch to this switch is typically through fiber optic cable. For bandwidth, also for distance, and also for fiber optic is made out of glass. It's an insulator for electrical isolation. If we have an electrical short in this closet, it's not going to travel across this link here to the other closet. So that fiber optic link there is allowing us to do some electrical isolation. We'll come back in the last podcast and tackle the last little bit of the chapter.